on the test, will it be more clear like what the height is and what, like, because like I used 14.5 as the side length instead, or no, I used 15 as the side length instead of 14.5.
Okay, so you need to be able to realize that the base shape is what you have two of. So this tells me that if this back here is 14.5, then so is this, and so is this. So you're gonna have to look to see what shape you have two of. And then that's how you can determine which is the side length. So it's not gonna be labeled clearly and say 14.5 is the S and 15 is the height. You're gonna have to look at the picture yourself. And you also have to remember that it's not always sitting on its base, and that was the situation here on example 1. So you're gonna have to practice trying to figure out what all the numbers represent, because it won't be clearly labeled. You have to be able to figure that out. Then here's number 2 again. And again, it wasn't given as a picture, but what was nice is they gave you the description. And again, they told you base height, base length, and then height of the prism. So sometimes maybe without a picture it might be easier, especially if they're very descriptive. Everybody good on 1 and 2 now? Let's go to 3. So here is this is a right cylinder. So again, a picture wasn't provided, so I drew one. So it says to find the volume. Again, same formula. The only difference is my base is now a circle. And the formula for area of a circle is pi r squared. So the formula for volume is pi r squared height. Notice they gave me a diameter, so I needed to cut it in half and make it a radius, because that's what I needed in the formula. So then once I got my radius equals 7 and my height equals 30, then I could just plug these numbers into the formula, and I ended up with 1,470 pi. Now, if on the test, because it'll be multiple choice, if you see that the answers have decimals, then you know you would be using the pi button and multiply 1,470 times pi. But most of the time your answers are going to be left in terms of pi. Everybody good on example 3? Let's go to 4. Okay, here is a nice standardized test question. You might see it on an SAT or a PSAT. So here it says a cylindrical beaker with a diameter of 10. So I drew my cylinder, and a height of 12 is filled with water and then poured into a rectangular pan. So this rectangular pan is like a rectangular prism. It wants us to know what's the volume of each solid, and would the water overflow the pan. So what we're going to do is we would find the volume of each. Remember, the formula is the same. The formula for volume is area of the bottom times the height. However, the difference between the cylinder and the rectangular pan is the shape, or the base shape on the cylinder is a circle, but my base shape on the rectangular pan is a rectangle. So here for the cylinder, it's pi r squared height, but for the rectangular pan, it's really just base times height, or length times width times height. Either way. So you're going to calculate the area of each, the volume of each. So the volume of the cylinder is 300 pi. Now, if they ask you to actually do the problem, then I would have actually had to multiply 300 times pi. And let's say I just use 314, that would give me about 942. So obviously this cylinder is going to hold a lot more. The cylinder is going to hold like 942 cubic inches, whereas the rectangular pan is only 378. So yes, it would overflow, and the amount it would overflow by would be about, let's see, my answer got cut off here, so this should be a 4 here, 364. So that's how much it would overflow by. So again, this would be a nice standardized test question Probably something you might see on an SAT. Pretty good on that one. All right. Now let's go through the homework. Now I'm going to zoom in on each one so you can see the answer and how I worked it out. So for number 3, this one was a multiple choice question, and it said how many 3-inch cubes can fit completely in a box that is 15 inches long, 3 inches wide, and 3 inches tall. So again, here what I need to do is volume of that box, so the area of the base times how tall it is, or just multiply 15 times 9 times 3, and I get 405. I also need to figure out the volume of one of these cubes, and a shortcut formula for volume of a cube is just side to the third power. So if I do 3 to the third power, each cube is 27 inches cubed. So then now I take the 405, divide it by 27, and I get 15. Then number 4 and 5, these are sort of like our complex figures, where I need to split it up into smaller shapes. So for number 4, I'm going to take care of the volume of this first rectangular prism up top here, and then I'll do this one over here. So the volume of the top one is 2 times 3 times 1, and I get 6. And then the volume of the bottom one is going to be 7 times 2 times 1, which is 14. Then I take these two, add them, and then the volume of this complex figure here is going to be 20 units cubed.
Miss Corey?
Yes.
Can we go back to number 3? I'm still confused.
Okay. Hold on here for a second. Okay.
Why did you divide by 27?
Okay, because the question said how many 3-inch cubes can fit in there. It didn't ask for the volume of it. You had to figure out the volume, but then you had to go back and you had to divide it by the volume of one of the cubes. Does that make sense?
Like, how did you know to do like 5 cubed and 3 cubed is 27? Like, how did you?
Oh, that's not that's an S. So a shortcut way of doing volume of a cube is just to take the side length, this is an S, and do it to the third power. Because remember, when you have a cube, the length, the width, and the height are all the same.
Oh, okay.
Okay, so this is an S that's here. So it's just side to the third power, and it was right here. The side length was 3. So I just did 3 to the third power. So I knew each cube was 27 inches cubed. And I had to figure out how many of these cubes would fit into the box. Does that make sense?
Yeah.
Okay. All right, then number 5, again, you're gonna split it up into 2 separate rectangular prisms. So I'm gonna first do the top red one. And this has dimensions of 1, 4, and 2. And then I had to do the bottom rectangular prism, 5 times 1 times 2. And then add the 2 volumes together. And you get 18 units cubed. Pretty good on that? All right, next one. Number 7. This is a triangular prism. Again, you're gonna do the area of the base times how tall it is. This time it's actually sitting on its base. So notice here, this is the base times height. So 7 times 10, divide by 2, and then times by the height. and then multiply it all together, and you get 175 inches cubed. Then number 8, this is a rectangular prism. And again, it's area of the base, which you could either do base times height or length times width. Just remember, when it's a rectangular prism, the volume is just length times width times height. So 4 times 2 times 1.5, and you get 12 meters cubed. Number 10, this is a cylinder. The formula for a cylinder is pi r squared times height, because the base shape is a circle. Again, they gave me a radius and they gave me the height. Just plug it in. So if they left it in terms of pi, the answer would be 588 pi. If they ask you to round to a decimal place and use your pi button, then rounded to the hundredths place would be 1847.26. And again, volume is always whatever the units are cubed. Number 11, another cylinder. This time they gave me a diameter. So I had to take this diameter that was a 10, divide it by 2 to make the radius of 5. And then the 16 is the height. So again, pi r squared times height, and you get 400 pi. Or again, if you're using your pi button, you would get 1256.64. And again, inches cubed. Number 14, they ask you to sketch the rectangular prism. Now, notice on this, the units are different. I don't know if you caught that, but they gave us 11 inches, 7 feet, and 3 feet. So I needed to convert my feet into inches. Always make the larger unit smaller, it's easier. So then once I converted them, then I could do the volume. And that's what I did over here. Now, I gave my answer both ways. So if you actually converted this 11 inches into feet, then your answer is 19.25 feet cubed. But if you left it in inches, then it's 33,264 inches cubed. So either way, be very careful and watch the units to make sure to see if you have to convert them within the problem first. Then number 15, this is this present. So over here for 15, it's giving us the volume already calculated. So what we needed to do was take that volume, plug it in, and then solve for x. Remember, whenever it is a cube like this, notice all sides, the length, the width, and the height are all the same. So this is a cube. So x times x times x, which gives you x to the third power. To solve this, you have to cube root both sides, and each side would be 10. For 16,
Wait,
now,
when you square root it, how did you get 10?
okay, it's a cube root because I got x to the third power, because x times x times x. And then when I try to find what number times itself 3 times, that gives me 1,000. That's going to be 10. Because 10 times...
The square root on the calculator won't work.
Right. Some calculators will do a third root, but on this, you would just have to guess and test.
Okay.
Okay. All right. Now, the next one was a bit challenging because notice my base is a triangle, but it's not a right triangle. So I actually had to take my base shape, which is the triangle here, and then split it and turn it into a right triangle. So once I took this base, which had a 5 here and a 9, soon as I drop in my altitude, it forms a right triangle. And then I had to do Pythagorean theorem to get the height of that triangle base. Once I did that, and because we're using a calculator, the height of the triangle base is 8.65. Then I can do the formula for area of my base, 1/2 base times height. It was a triangle. The area of my base is 21.615. And now to find the height, which is x, I'm going to work backwards. They gave me the volume already calculated. It was 45. Set that equal to the 21.615x. So the height of this piece of cheese, which is a triangular prism, is going to be 2.08 centimeters. And then number 17 looks like a cylinder. And here again they gave us the volume already calculated in terms of pi. So again, volume of a cylinder is pi r squared height. So again, I'm going to set 128 pi equal to the formula. Notice this is a diameter, this x. So to turn it into a radius, I have to divide it by 2. And that's how I got x over 2. So then you do x over 2 squared times 8 times pi. Once I square, it becomes this. And then if I times it by 8, I can simplify. And then that's how I turn it into 2 pi x squared. And then and then 128 divided by 2 is 64. Now we square root it and we get x to be 8.